Here we're going to look at question 12 from section 2 of the ENGAA 2018 paper. In this question we're given the following circuit, which shows a battery with an EMF of 6 volts, and also has an internal resistance denoted here by small r. This battery is connected in parallel with two different resistors, one of 20 ohms and one of 30 ohms. We're told that the voltage across the 20 ohm resistor is going to be 4.8 volts, and then finally the question asks us, what is the internal resistance of our battery? So if you'd like to have a go at answering this question yourself, then please pause the video now, otherwise let's have a go at it. So I think the best thing to do with it, whenever you have a circuits question, is to at least consider whether or not you can redraw the circuit in a more useful way. So that's what I think we're going to have a go at doing here. Now we know we have this parallel section, but we also have our internal resistance. Well, how about we bring our internal resistance out into the circuit properly and treat it like a normal resistor rather than treating it as this resistor inside the battery, which you're totally allowed to do. This dotted box around the battery doesn't actually mean anything physical. So if we do that, then our circuit can look like this. Now hopefully this is a much more familiar sort of looking circuit, since it's just a single resistor in series with this parallel section made up of two different resistors. The next thing to notice as well is that we have 4.8 volts across our 20 ohm resistor, but since these two resistors are in parallel, we know the voltage across them both is going to be the same. So they both can have a voltage of 4.8 volts across them. Then we also know that by Kirchhoff's voltage law, the voltage in a loop should sort of cancel out, they should be the same. So if we have 6 volts coming from the battery here, and then 4.8 volts across this parallel section here, then we know that the voltage going across our internal resistor has to be 1.2 volts. And now with this, we can go ahead and try and think about what our internal resistance R is actually going to be. So if we look at our configuration here, then we notice that actually we have a potential divider going on here. So we have the internal resistance, and then we have this parallel section. Then this voltage, 1.2 volts, across our internal resistance R, can be written like this. So our 1.2 volts is just the fraction of the 6 volts that our resistance makes up, our internal resistance makes up of the total resistance of our circuit, with RP here denoting the resistance of our whole parallel section here. So this is just the expression for a normal potential divider. However, normally when we do something like this, we're trying to find out the voltage across the element, not the resistance, but it's exactly the same thing, just different unknowns. Then of course we can rearrange this to get this by dividing by our 6, and then with a small bit of algebra, multiplying both sides by 5, and then our small r plus rp, and then taking away one of the r's, we get that small r, the internal resistance, is equal to the resistance of our parallel section divided by 4. Right, so this is going to make sense because here we have a fifth of our 6 volts being used up, if you like, across our internal resistance, and then the other 4/5 are being used up across our parallel section in our 4.8 volts. But now with this, the only thing that's left to do is to try and find this resistance of the parallel section. So how are we going to go about finding this resistance of the parallel section? Well, the reciprocal of this resistance is just going to be the reciprocals of our two resistances added together, which of course we can write up here, and then by multiplying through each of the fractions a bit, we get that this is just equal to 3 over 60 plus 2 over 60, which is just 5 over 60 or 1/12. And then flipping this, we get that the resistance of our parallel section is just 12 ohms. Now with this, we can just substitute our 12 ohms into our expression for the internal resistance, small r, and dividing this by 4, we get that the internal resistance is just 3 ohms, which is going to correspond to answer D given in our question.